Hello everybody. So today's lecture is on installation of lighting equipment, section 30, but a lot of this module is actually outside of the code book. So a lot of this module does require some memorization for tests, exams, and the TQ. That's just kind of an unfortunate part of this module, and the extra unfortunate part is since it requires a little bit of memorization, it's also a very large module. So let's get into it. First thing we're going to talk about is what's known as the electromagnetic spectrum. So there's different wavelengths of electromagnetic waves, if you want to think of it that way, from cosmic rays, and their length is 10 to the negative 14, all the way up to, very low frequency, low, medium, high frequency wavelengths. Radio would be a high frequency wavelength. What we're focusing on more is, since this is the lighting module, is illumination, or this visible light spectrum that humans can actually see. We don't, as you can tell from the different wavelengths and where, our very limited vision in here, we don't see as well as maybe we think we do. Now, another one to think about in terms of wavelengths is this. They have radiant heating labeled right here. And so if you think about a fire, that produces heat and it produces light. However, a baseboard heater that also produces heat does not produce light. At least not very much, not unless it gets very, very hot. Another example of radiant heating would be the elements on your stove. The element on your stove, it might get red. It creates a little bit of light, but it's more designed to create heat. And the light it creates maybe is not visible to us. Maybe only some of it is. And that's in the infrared spectrum. There's also UV lights that have a different purpose than just lighting up a room or lighting up a space or an area. So we care more about this human vision when we're installing lighting, because we install lighting to, like I just said, light up an area, maybe light up a street at night, light up your house, basement, flashlights and portable lights, light up spaces that don't have lights installed. Now, normally we like some kind of white, yellowish light in general to light up spaces. And so some types of bulbs, or as we're going to learn, we call them lamps, have a yellowish light, whereas LEDs, the kind of growing hot thing in lighting, produce more of a white light. And the reason LEDs can do that is because white light basically contains all the other types of light. So you can think of it either way, but this is a prism that breaks up white light into all the other colors of light. White light contains all the colors of the spectrum, as I just said. Black, or the color black, is the absence of light. And so if you've ever seen an LED that can change colors, it's because it already has all the colors available if it can make white light. Or some bulbs make just one specific color. And you can change the color of an LED, and you're basically changing the wavelength. So some of the definitions and memorization that I talked about at the beginning start to come up early on in the module. Now, the more candles you have, the more light you have, in a very in a very basic sense. So candles, they produce heat and light. They're not very good at producing light, but until we had electricity, they were our primary way of producing light, as a candle or a torch or some kind of source of fire. And what we're going to start to talk about, and we have sort of 3 new terms to learn. A candela is basically just one candle, if you want to think of it that way, a candela. We have lux, and we have lumen. So more candela, more light. Candela is kind of our base, or the root of these other 2 terms, because one candle burning for 1 second gives us a lumen. And when they talk about illumination, they're going to talk about lux, because lux is a lumen per meter squared. So from here to here is 1 meter. Here to here is 1 meter, and that's how they get a meter squared, in case you're wondering. So 1 candle per second, per 1 second, over a meter squared would also be our lux. So candela, lumen, lux are some new terms. So these are types of incandescent bulbs, and they're different bases. Mogul, as it may be obvious, is the largest base. Medium base, the most common for sure. Most of the lights in your house, the general lighting, is going to be a medium base type of socket or lamp holder, as we'll start to talk about. And incandescents have these little filaments in them, a tungsten filament. And what we do is we send current from our source through these tungsten elements, or filaments, sorry. And so as we send current through the tungsten filament, it gets hot, as most things do when we send current through them. If you think back to our section 4 in calculating or figuring out wire sizes, a lot of that had to do with the fact that when we put current on a wire, the wire can get hot. And it's the same with most of the things that we put current on. We send current through baseboard heaters. We send current through stove and oven elements, and they get hot. So the current we send through this tungsten filament makes this filament get hot, and the heat it produces also produces visible light, or radiation, or electromagnetic radiation, that is on that wavelength spectrum. It's the wavelength that is visible light. Now, incandescents are usually a bit of a yellowish light. It's a little bit similar to sunlight, so if you think that incandescents give off better light than maybe a harsh white LED, that's because it's a little bit more similar to sunlight. Now, incandescents are basically phased out in Canada. I don't believe you can buy them many places anymore. You're not allowed to import them since about 10 years ago. You're not allowed to produce them since about 10 years ago. So most of these are phased out, but the base size is still relevant. Most of our modern LEDs have these types of bases as well, so that they can just fit right into existing light sockets, or luminaires and lamp holders. And we'll get into those 2 terms in a minute. But LEDs produce light in a different way, and they don't produce very much heat. So what we could say is that LEDs are more efficient, or a term you might come across is efficacy. And efficacy is basically, that's what we want to do. So when something has high efficacy, it's doing what we want it to do better. So LEDs have high efficacy, and they're more efficient because they lose less power to heat. Whereas incandescents, most of their power is heat, and that heat produces light. Now, one thing that is more efficient than an incandescent was these are still installed. I think they're still available. I bought one of these recently for a fixture in a bathroom. But these are halogen lights. Now, they burn much hotter, so turn that light off and give it a few minutes, because that will frickin' burn you, this little thing. But the halogen burns hotter, and so it's a bit more efficient than the incandescent. But because it's still using heat to produce light, it's still it's still losing some of its energy just to heat. But these are more efficient than LEDs, and they're usually used in this kind of floodlight capacity, or track lighting and kind of little spot lighting. If you've ever seen or been to some art galleries, for example, we'll have a painting up on the wall, and they'll usually have a little light up here. That's a halogen, because it's very bright, and because of the design of these, they target that light onto the painting, or what they want you to look at. So those are halogens. And now we're going to start talking about lamps and lights that are controlled by ballasts. So an incandescent in a halogen has the light socket that we put the bulb into. And that light socket usually has like a brass screw and like a silver screw. And we just take our wires. There's my live wire, there's my identified wire, and that makes the light bright. We just send current through it. Heats the filament up, produces light. But some bulbs use a ballast. And so this ballast, instead, if we were to draw a schematic diagram, for example, we would come into the ballast, which would then go to the light socket. And now the ballast is in control of what these lights will receive in terms of electrical energy. And ballasts are in fluorescence. They're used in CFLs, which are compact fluorescence, They're also used in HID, or high intensity discharge types of lamps and lights. So let's look at some of these lamps that have ballasts controlling the electrical energy to them. So here are just some types of fluorescence. And so what the ballast is going to do for all of our HID types of lamps, or electric discharge lighting, is it's going to basically light the gas that is inside of these types of lamps. So most of these, I believe it has it labeled on most of them, but aside from the LED types of these lamps, these old style fluorescents have Hg on them, meaning they have mercury. Hg is just the chemical or the periodic table symbol for mercury, or mercury, if you will. So now we don't have a filament that's putting off heat, which produces light. Now we're igniting a gas, which produces light and some heat still, but now we're far more efficient than a halogen or an incandescent, But the problem being now we have a ballast. So now there's some extra components. Usually when you see these bulbs or these lamps acting funny, usually it's a bad ballast. And just to go back to the ballast picture for a second, if you're changing out one of these old style types of ballast, this electromagnetic ballast, they are quite heavy. They can also be very, very hot. And sometimes they crack and leak out all these nasty things, which can be also hot. So just be careful and watch yourself. But be extra careful that you're replacing the ballast with the correct or the same ballast, basically. Because different types of lamps require specific types of ballasts. So these are fluorescents, and they need a ballast. There's also compact fluorescents. Now these guys have a ballast built in. These were going to be, sort of the replacement for incandescents. They require some extra recycling as well because they have these little electronic components. But the benefit of a residential application is you don't have to change out the ballast. You don't need an electrician to come and change out these bulbs, these lamps, because they already have the ballast built in. But of course, now that you have a ballast, which is lighting this gas inside here, you have an extra cost involved versus incandescents, which were always pretty cheap. So these are CFL, and that's compact fluorescent lamp. These are not involved with the gray cup. These are just lamps. And then we have the NFL, or non-CFL. Sorry for the lame sports joke, but these don't have a ballast built in. So whatever you plug these into, and you can see they don't have that normal incandescent type of sort of threaded screw base. These wouldn't fit in a regular light fixture in your house. These are designed to fit in a light that has a ballast because these don't have the ballast in them. They just have a connection point and the gas in these tubes. Now I should make a correction in case I misspoke earlier, because everything that has a ballast is electric discharge lighting. However, these are the high intensity discharge lamps. These are the HID lamps. And so instead of just a ballast kind of controlling the energy and lighting the gas, now, as you can see in these clear or transparent glass bulbs, these actually have a large filament sort of that functions as an igniter. This is what it means when it says high intensity discharge. It builds up this large arc, and if you've ever seen one of these bulbs turn on, you will actually see like some kind of spark or ignition of the gas. So these are high pressure sodium. There's also low pressure sodium. This is a mercury vapor, and then we have metal halide. So these bulbs are quite efficient, still not quite as good as LEDs in terms of just making light. These bulbs can also get, somewhat hot as well. But the reason that we're not using these or never use them very much inside our homes is because they still have a ballast, and that ballast controls the energy, which sparks this gas inside of here, which produces light. But that ballast can sometimes have a bit of a hum or a whine. It's this white noise that we don't really like. So we don't usually use these indoors in residential. They also have very large, these mogul bases. compared to this, this is your 60-watt medium base incandescent. So that mogul base is the largest screw style lamp holder base. So another reason that these are not common indoors and residential, but warehouses used to have these all the time. Outdoors, maybe on like a farm or just some general bright outdoor lighting where you just need a lot of light, and maybe you have a trained electrician, or you call an electrician when the ballast stops working for these light fixtures. Now, because of the light and the way these give off light, some of these are used for indoor growing plant operations, if you will. And then we have the type of lighting that everything is compared to, LEDs. Now, your module doesn't talk about LEDs very much. They are probably just a little bit behind, I guess, in the times. Maybe they don't think LEDs are going to stay. So there's not much you need to memorize for LEDs. But I just wanted to talk about the symbol for LEDs to kind of get us thinking about how they work. Excuse me. So each one of these little yellow dots here is a light emitting diode. And so depending on how you want to arrange them, you could arrange them like this. You could have them just on a strip that has an adhesive on the back, and you could just slap that under the counter and just plug it in. LEDs need some type of driver, which sort of functions as a ballast, if you want to think of it that way. But this is the symbol for an LED. I should say this is a symbol for a diode. I believe an LED actually has some kind of light rays coming off it or something to that degree. But all the same, the way this functions is we can send current this way, but current will not go this way. That's why this line is here and the arrow is here. So as we send current through, and they don't use very much current, they don't produce much heat, light emitting diodes. They're designed and made to, create light, hence their name. And so we send current through them. There's a bit of heat, but they mostly produce light. And then when we stop sending current through, this closes, essentially. Now that's electronics, and that's usually dealt with in fourth period electrical, but all the same, it's good for electricians to know kind of what's going on in these little diodes. And so if you have a bulb, an LED bulb, it has these light emitting diodes usually just kind of arranged in some kind of fashion to send light out everywhere in a similar way that our incandescents do. And so in this section, we have the electronics and the little driver. So practically speaking, for the average homeowner, they can take an incandescent and put an LED in, and it seems to function the same. And different LEDs can produce different types of wavelengths, so it can, give a more desirable color or type of light depending on what people like. But yeah, that's kind of the way the industry is going, is towards LEDs. Your module doesn't talk about it much, but all the same, it's good for us to know in general as electricians. And so what we put our lamps into, and all those things we talked about, incandescents, LEDs, HID type bulbs, fluorescents, compact fluorescents, they're all called lamps. And so we put our lamps into lamp holders. These are all types of lamp holders. These would be for fluorescents. Sometimes these are called tombstones in the field. And when we secure the lamp holder or when we have a complete assembly of a lamp holder attached to some kind of thing that, we're actually going to install, this would be called the luminaire. So usually just called the light, but in code class and in this lighting module, this is referred to as a luminaire. So this has a couple lamp holders inside of here. It has some conductors coming up from those lamp holders going into something. And then we terminate our wires for the light to that junction box that these conductors are going to. And that takes power down to here, which carries them down to the lamp holders. We screw in lamps to the lamp holders, probably 3 in this type, and those lamps produce light. Now finally, oh my gosh, thank goodness. Finally, we're back into the code book. Whew. I know you were all missing this big, beautiful book. Now, to me, I like modules and code that deal with the code book because I know that I will have this on an exam, on the TQ. But this module deals with things outside of the code book, as I said. But it also is mostly related to Section 30, installation of lighting equipment. Now, if you have installed lights in residential electrical, or you've installed residential lights, I should say, however you want to twist those words, you may already know what type of voltage and amperage those lights are. Normally they're almost always 120 volt, 15 amp, or they're 120 volt rated lights fed from a 15 amp breaker. Now, when I say residential, I'm talking about dwellings, not, for example, a farm, which has a mixture of farm areas and maybe one or multiple dwellings. Because when we talk about dwellings, we talk about houses and living areas and living spaces and living structures for humans, not livestock. But 120 volt lights in dwellings from a 15 amp breaker, is that what they have to be? Well, let's jump back to section 2. And 2.110, circuit voltage to ground dwelling units, tells me that branch circuits in dwelling units shall not have a voltage exceeding 150 volts to ground, except it's talking about service conductors, apartments, buildings, similar. It has these exceptions such as space heating, water heating, air conditioning. Now when it says 150 volts to ground, that would be between your live conductor or live terminal of a receptacle maybe, and your bond. So line to line, you might get 240 volts at a range receptacle, but line to ground would be about 120. So we're not exceeding 150 volts. Okay, so our lighting would have to fit into this, but this is a general section of the code, so maybe the specific section, which is section 30, has something else to say. At the bottom of that page, 3102, branch circuits shall not exceed 150 volts to ground in dwelling units. Okay, so kind of saying the same thing, but now we're talking specifically about lights. 3104, protection. So the maximum rating of an overcurrent device, protecting a branch circuit, containing luminaires, lamp holders, or lighting track, shall be as follows. Dwelling unit, 15 amps. Okay. Other than dwelling units, there's some other things that you can do. So in my office, I have 347 volt lighting. Now my office is not, and offices in general are not dwelling units. You're not supposed to be sleeping in an office. You're there to work, and then you go home to your dwelling. which has 15 amp, 120 volt lighting. Now, 3110 polarization of luminaires tells us what to do with the identified conductor. And it shall be attached to the luminaire terminal or insulated conductor that has been distinguished for identification or otherwise suitably marked unless the luminaire is suitable for connection to line voltage. Now, a luminaire that would be suitable for line voltage would be a 240 volt light. But of course, that's not that might not be in our dwelling unit. And what it means by polarization of luminaires and all this is when you connect, your black and white wires, commonly the black and white wire, to your luminaire, it will usually have a silver screw and a brass screw. Now, the screws aren't made of brass or silver. They're just kind of colored that way or coated. But your silver screw through the lamp holder is connected to this screw shell. And the reason the codebook is very specific about which wire goes to this screw shell is if somebody didn't turn the switch off for whatever reason and was going to change out a bulb, because if the bulb is burnt out, maybe they don't know that the switch is on or off, hypothetically, but either way, the codebook is telling us the identified wire is connected to this screw shell through the silver screw, so that as someone's taking the light bulb in or out, they are not touching a possibly energized piece of metal. The live part of this type of lamp holder is actually tucked in here. And so if you look at a light bulb, it has metal on the outside on the screw shell that connects to this. And it also has a little metal tip at the end which connects to the live part of the lamp holder. So that's what that rule is talking about when it says that you shall polarize your luminaires correctly. Now, a much easier to understand picture, I won't say better, but this is more of what we as electricians will see, is exactly this. You have this is the luminaire, and this screw shell on the outside that the bulb is going to screw into is connected to this silver screw. So our white grounded conductor, the identified wire, I have two wires here, so I know that that's my identified wire. That goes to the silver screw. Now, some lamps create heat when we use them as a light source, as we talked about. And the codebook is going to tell us that if it's above ignitable fibers, such as in a closet, you cannot have a bare lamp, this type of light. If you had sometimes called a boob light, or some kind of light, they look like this. I'll draw a side profile of it. Some kind of light that has the lamp holders but is covered by some kind of shroud of some kind that is attached to the luminaire. That's not a bare lamp type of luminaire. Now, the problem with this is not only does it give off heat, and that heat is just going right down to ignitable fibers, something that is combustible. The other problem is if this lamp were to break, well, now you have all that, hot projectiles falling down onto ignitable fibers. And if you just broke the glass and this filament was still ignited, well, now there's even more heat just getting dumped out of here. So we don't use this type of light above combustible things. And there are combustible things in a closet, because normally you would put clothing in a closet. Now, another reason we don't use this type of luminaire, which is usually called a pull chain lamp holder or pull chain light, because of this chain which acts as the switch. There's also these types of lights. Not sure if you can see that. There's a switch right here. Look at the pictures in your module. It might be easier to see. But these are luminaires with integral switches or built-in switches, sometimes called canopy switches. So the canopy of the luminaire has the switch. These are also not allowed in closets. The lights in your closet need to have their own switches, usually a switch that's located on the wall as you walk into the closet. So if the light is causing some kind of combustion, you can turn off the light without going into the closet. And so these are the code rules talking about exactly what I was talking about. Luminaires installed near or over combustible material shall be equipped with shades or guards to limit the temperature to which the combustible material may be subject to a maximum of 90 degrees Celsius. And sub-rule 2 is saying installed under the conditions. So for combustible near or over that are, limited with these or protected by these shades or guards shall be of the unswitched type, which means they don't have a switch built in. Now we also have height requirements for luminaires near or over combustible stuff. We can't have exposed wiring. Sure, okay, that kind of makes sense as well. We also have clothes closets, which are a bit more specific. It's telling us that we are going to have luminaires installed on the ceiling or on the front wall above the door of the closet. So it can't be on the back wall of the closet. We also can't have pendants, so like chain lighting that hangs down. Or we also can't have the bare lamp type, once again, because clothes closets are, maybe you have a shelf that's just stacked to the brim with wool sweaters. You don't want those lights lighting your nice wool sweaters on fire, especially when, if it's wintertime, you're going to want to use those wool sweaters. So we have specific rules for clothes closets and where we put our lights. Now you may be wondering why location of lighting equipment doesn't have a bunch of rules for how many lights in a house and all those kind of measurements and things like we did for receptacles in a dwelling. And in Appendix G, I will show you exactly where we can locate the information about amount of lights given a meters squared measurement of a house. And so way back in the bowels of the code book is Appendix G. For my code book, it's page 809. And in Appendix G, it's basically telling us about the National Building Code of Canada. Now, the 2015 edition of the National Building Code of Canada is equivalent to the 2019 Alberta edition. Now, you don't need to know that for code, but in case you're wondering, outlets and dwelling units from section 30, this number right here is the building code rule number, if you want to think of it that way. So a lamp holder is a type of outlet specifically for lamps, hence the name. And I kind of copied this rule, and I'll show you exactly what it looks like. And so here is I just copied this from the National Building Code of Canada, 9.34.2.2. And it's telling me, except as provided in sentence 2, which It's probably this sentence. They don't say sub-rule 2. They're a little different, I guess. That's fine. A lighting outlet with fixture controlled by a wall switch, controlled by a wall switch, shall be provided in kitchens, bedrooms, living rooms, utility rooms, laundry rooms, dining rooms, bathrooms, water closet rooms, vestibules, and hallways in dwelling units. We're a receptacle controlled by a wall switch, so sometimes we will have a switch on a wall, and then over here we will have a receptacle, and that switch controls half of the duplex receptacle. And so when you plug a lamp in, which may be confusing because we're in the lighting section, but when you plug in one of these standalone lamps, which is actually a luminaire, as we know now, and you got your bulb in there, and this switch turns on this half of the receptacle, the building code is saying, yeah, that counts as an outlet for lighting. So just wanted to sort of explain where we find out how to put lights in to code, and it's not in the electrical code, it's in the building code. So we're not going to install these lights and fixtures and luminaires just so that they can fall or not be supported correctly. And so to find out our minimum standard as per the Canadian Electrical Code, we go to 30302 or 30-302 for supports. And okay, sub-rule 1, it's one that certainly makes sense. Every luminaire shall be securely supported. Okay, yep, we need to make sure they're supported. That's maybe one of the most straightforward sub-rules or rules in all of the code book. 2 is going to tell us that where a luminaire weighs more than 2.7 kilograms, or exceeds 400 millimeters in any dimension, it shall not be supported by the screw shell of the lamp holder. So that screw shell, we were looking at that for the polarization rule, but that screw shell is here. So you can't have something heavy hanging just by the threads of this screw shell. That's not going to be able to take very much weight. And you can't have anything that's either hanging down or is, exceeding 400 millimeters across or down, or, maybe it's pointing up this way, whichever. It can't exceed 400 millimeters in any dimension. So if this shade that is just kind of sitting on the bulb, this was 400 millimeters, that'd be fine, as long as it didn't make the whole thing, the lamp and the shade, as long as it did not make both of them more than 2.7 kilograms. Back to our rule. So rule 3 is talking about where the weight of a luminaire does not exceed 13 kilograms. The luminaire shall be permitted to be supported by a wall outlet box attached directly to the building structure, or by a wall outlet box attached to a bar hanger. So, for example, some kind of maybe a wall sconce, if you want to be fancy. Don't mix up sconces and scones. Those are totally different things. One you eat, one you install, if you're an electrician. But if we think about this box right here is attached to the structure, right? This octagon box is screwed to this, maybe this is a stud or something that is structurally attached to the building. The force of gravity is going to be pulling down. So it's not going to be evenly pulling on all of the supports of this box. It's going to be a little uneven, pulling straight down. So we can't be over 13 kilograms for a light on a wall, But for a light attached to a ceiling, which is, maybe the more common way we install lights, we could have more weight, or we have a larger amount of kilograms that we cannot exceed, however you want to look at it. Now, what it said in both subrule 3 and 4, it talked about a bar hanger. Now, this is something that's designed specifically for electrical boxes. It's made specifically for this application. It's essentially going to provide us with, or the code book tells us at least, it's providing us with the same sort of support as if we attach this box right to the stud or a structural part of the building. And now we can go up to 23 kilograms, but not more. Subrule 4, so supported by a ceiling outlet box, not a wall outlet box. Now, these may be the same box. They may both be an octagon. You buy the exact same part number. But if it's attached to a wall, the rules are different for, the weight of the light or the luminaire versus if it was attached to a ceiling. Now, subrule 6 says don't use rigid PVC unless they say they're meant to have a light hanging from it. Subrule 5 is now saying, okay, well, if you have some kind of huge monstrosity of a light that you look at and you go, biscuit, or some other actual curse word. Biscuit's obviously not a real curse word. But if you're upset about the weight of the light and you're like, does the octagon even support it? Well, no. Because where the weight of a luminaire prohibits the installation methods specified in 3 or 4, the luminaire shall be supported independently of the outlet box or by a fixture hanger provided with an integral outlet box suitable for the purpose. So either you get an all-in-one support outlet box, or you just support the light independently of the box. So this example, this light, it still has wires. The cable comes into the junction box up here, and the wires for the luminaire are going to be spliced into here. But the fixture itself, this whole luminaire, is supported by this post running through, and it's attached to this, possibly a wood stud or maybe a piece, a metal piece of structural support, which is attached to the building. So this is if that light is too heavy, you have to just support the light. We still need a junction box. And that junction box is still probably attached to this light in some way, but the junction box is not carrying the weight of the luminaire. Now, I have also seen, an extreme example where the light was both heavy and very high up. So what they had for that example is an actual winch in the ceiling. And it had a, structurally supported cable that wound around a wheel up in the attic space, and that came down to the light. And I was the poor, unfortunate apprentice who had to crawl, well, my head's going to hit the ceiling there, but all the same, I had to crawl through the ceiling with this winch and put it in place. So obviously they had some extra cable because to change the lamps of that chandelier, as the winch lowered the chandelier, the conductor would have to go with it. And so that's another way, if you're someone building a mansion and you want a chandelier that is just a monstrosity and you don't want to get a scissor lift or some kind of massive ladder to change the bulbs, you just get some poor, unfortunate apprentice to carry a winch through the ceiling, put it in place, bolt it down to the structure, because even though there's this big heavy winch, it still has to be attached to the structure of the building. And then that steel cable is going to be what holds up this light, and you could lower it and raise it. So that's subrule 5 in the making, in my experience. Now, once again, we have a recessed luminaire, such as, if you've ever seen lights laid in T-bar, That would be a recessed luminaire. Or pot lights in homes. Those are recessed luminaires. We call them pot lights, but they do have a specific name in the code book. And once again, we're worried about heat. Now, 3902 lays it out pretty simple. It just says depending on the type, depends on how close insulation and combustible materials can be, aside from, what it's attached to. So obviously if this pot light was attached to a stud, a wood stud, well, that would be combustible material. But aside from what it's attached to, you don't have combustible material within 13 millimeters, and you don't have thermal insulation. So you don't just take a big piece of pink, itchy fiberglass and lay it on top of this, because that's going to make this light overheat. Has a good chance. So at least 76 millimeters. Usually you would just leave no insulation in this area. You would insulate up to, kind of close, and then they would just leave none. Hopefully. Sometimes other trades are involved, and sometimes other trades mess up our stuff. But this is what the code rule is talking about. Now this guy, this type IC, well, it's got its own protection. Right? It has this metal box that's now protecting the luminaire. It's just keeping everything away from it. So this type of luminaire could have insulation, that big pink stuff laying right on top of it. Sure, it doesn't care. It's dealing with its own business. It's got itself protected. And you can see the junction box on the side here, which is where you would actually bring your NMD90 cable right into, or BX, or whatever type of cable is going to this light. You don't really put raceways to cable, raceways to lights, usually, not these types of lights. But all the same, that's the junction box. That's where the wires from the lamp holder go to, and this whole thing would be our luminaire. Now, sometimes, this is usually an older installation thing that I've seen, but sometimes there is a cable going from the light to a receptacle. Sure, that's fine. That's not a common way that we give power to lights, but it's a way you could do it. Maybe you want to switch this receptacle. Sure, if you want to turn this light off and on. Maybe it's a temporary setup, and you're just plugging in that light temporarily. Sure, either way, all we care about, or one thing we care about a bunch of things, but this is not just going to be BX or NMD. This is going to be a flexible cord or cable. We find table 11. We find something that's good for hard usage in this temperature, because we're dealing with lighting. There's going to be heat in this area around the light. And we can use section 4's flexible cords and cables for sizing them based on ampacity. We got section 12, the 12400 rules for using this flexible cord or cable. So back to this picture again. This is a keyless lamp holder, and this is our lamp. All right. And we got 14 gauge wire coming in. We'll have 120 volts on this wire, almost always. And we have our white wire or the identified wire going to the silver screw. Okay, all that good stuff. We have 14 gauge wire coming in. Sure, that's pretty normal. There's nothing out of the ordinary here. But what's going on here? Sometimes you'll have a light like this. This is kind of a common setup. It has this big sort of plate to cover the junction box on the ceiling. And you'll have these little wires that are not 14 gauge coming down from your light fixture, from the luminaire. Now, why are those allowed to be 18 gauge? Does nobody check that? No inspector has ever looked at the wiring of a luminaire? No, of course not. It's because 30404, conductor insulation, luminaire shall be connected with conductors at least 18 gauge, having insulation suitable for the voltage and temperatures to which the conductors may be subjected. So these wires are not going to handle the full ampacity of the circuit, so they shouldn't melt or burn up. They're rated for 90 degrees Celsius because they're going to be in very close contact with the luminaire. But let's go back and look at some other rules that kind of confirm and lead us to 3404, just to kind of do a exploratory look at the code book and make sure everything's lining up between the sections. So now we're back in 14104, that fabulous rule that is 14104, which tells us that the rating or setting of overcurrent devices shall not exceed the allowable ampacity of the conductors they protect, except, so a 15 amp breaker on an 18 gauge wire, that probably 15 amps probably exceeds the allowable ampacity of 18 gauge wires. But as it says in section 14 is a general section. It says as provided by other rules of this code. So since lighting is a specific or a boss section or a supplementary section, and it says you can use 18 gauge for luminaires in this capacity, then 18 gauge is allowed. So, the code book between the sections are getting along just fine. Now, one thing that is missing from this picture from before for this pull chain keyless lamp holder, this pull chain lamp holder, is that this part of this chain or part of this chain will be insulated, so that should this, it's all metal that's connected to itself, should this part inside, which uses the switching mechanism, should that for some reason become energized, when you go to turn this light on and pull this chain, you won't get electrocuted. And we can find that right here. Luminaires with pull type switch mechanisms. It's exactly what that little chain is. On luminaires employing pull type switch mechanisms, the operating means shall be cords made of insulating materials. So maybe it's like a twine or a thin rope that's coming down. Metal chains without insulating links, provided the lamp holder does not require insulating links, or cords made of insulating materials or chains with links made of insulating material connected to metal chains as close as possible to where the chains emerge from the enclosure. So basically we need to have this insulated to some degree is a way to read those rules. Now, pendant lights have some specific rules. Normally, this junction box, normally the luminaire is attached to this junction box. And this junction box, should it be metal, it shall be bonded. So maybe this is EMT coming in, and the EMT is the bonding means. Maybe there's a separate bonding conductor pulled in. Don't care. Just has to be bonded somehow. But this down here is not a low impedance uninterrupted path to this box up here that is bonded. This part of it is bonded, but down here has these loose chains. These chains are not structurally attached to each other. It's meant so that should you bump this light, and this light is hanging down, the light can move and it'll swing. And if you see one with a chain, maybe go and tap it a bit and you'll see it just kind of swing to and fro. Now, there's specific rules for the gauges of these wires, depending on what type of lamp holder is down here. And aside from section 4 that says, you have to have a continuous color on conductors of certain sizes. For this type of light, it's saying, yeah, you can have these thin little tracers. You don't have to have an obvious, colored black, white, and green wire coming down to the lamp holder. Maybe that wouldn't look nice. So the code rule is saying, okay, yeah, you can use these little tracers so that by the time these conductors get up to the box, you know which is which. And so 30608 is telling us that depending on the base, so mogul or medium base, screw shell lamp holders, shall not be smaller than 14 gauge. And the candelabra base, that smaller type of screw shell lamp holder, shall not be smaller than number 18 gauge, other than Christmas tree and decorative lighting outfits. And 3402 is the rule that tells us about that color coding, the tracers, as it's called. And normally, based on section 10, that wire has to be green all the way. The green wire shall be the bonding and or grounding conductor. Or section 4 that says your white wire smaller than a certain size has to be white all the way through. Or your identified wire has to be white all the way through. Excuse me. But this is saying wiring of lighting equipment for color coding, so specific to lighting, it can have this tracer, so it's not the color is not so obvious, is the intention there. So that is the end of installation of lighting equipment. As always, send me questions if you have them.